Hello class and welcome to today's lesson on 4.3. Today's objective, we're going to describe overall pattern of data displays, and our essential question is what are the three things you need to know to describe overall pattern? With all videos, right, if you are struggling, take your time, pause the video, catch up with us, as I will move fairly quickly through this. So to start with, right, what are some examples of data displays, or we call them visual representations of data? Right, some of these you may have heard of, some of these you're going to see some examples of a little later. Right, anything that helps you see the distribution of data, right, the flow of the data, what does the data look like? Some examples, right, a pie chart, maybe we've heard of that, a line bar graph, a dot plot, stem and leaf plot, and then a box and whisker plot. We're going to learn all about all of those here this chapter. So to start with, right, what are the three things we need to know for overall pattern? That's right, these are three key words, ideas we need to know. And so to start with, I'll get this out of the way here. First one is center, right, the center of our data. So at the center, we actually have three ways to figure it out. Right, one is to find the mean, right? We should know the mean, right? You take the average, you add them all up, divide by the amount. Right, if we look at this figure, right, or this notation right here called X bar, right, you will see that on your calculator sometimes. That is just saying the average. That's right, this is calculator notation. Right, then median, right? Median is the middle number when the data is put in order, right? Key thing right there. When the data is put in order, again, calculator notation, it might just be MED. And our third one, not used as often, but it is used, right? It's called our mode, and it is the one that happens the most often, right? If we struggle with remembering that, right? MO, mode, happens most often. So right, that's our first thing, right? Called center. Our second one here is called spread. What are the smallest and largest values, ignoring any outliers? We'll talk about that here. Right, we have kind of two ways to do it. One, range, which you've probably heard of before, right? You take the max number minus the min number, and you have found your range. Sometimes we just ask for what is the spread, and you just go your minimum number to your maximum, right? So minimum number maybe was 3, your maximum was 15, so you could write it out as 3 to 15. And that would be your spread. The last one here, shape. Describe what the data looks like. Is it increasing, decreasing? Is it skewed, bell-shaped, etc.? Right? These are some words maybe we're not quite sure on yet, right? Bell-shaped, skewed. Right? We'll talk about those here actually in a couple slides. Include any deviations or outliers, right? That's going to be part of our shape, So again, pause it if you need to, but I am going to move forward here. So looking at this data, right? This was data asking us, what is your shoe size, right? And so we took, specifically, we took 18 people, and we took their shoe sizes and put them up here. So right, we want to find center, spread, shape. I notice shape, we need a data display for that. We're going to do that here in a little bit. But center, I'm going to go fairly quickly through this. Right, to find the mean, you would need to add all these up. Right, so you add them all up. And then we're going to divide by the total number of people. Right, so if we add all those up, we'd get 166.5. Then we divide by the number of people we had. Right, we're trying to find an average. And we would find that the average shoe size is 9.25. Now for this next one, I'm just going to talk through it real quick. Right, first step, you'd have to put the data in order. Notice it is not in order right now. Right, so your first one would be that 6. Right, you'd have to go 6 to 7 to 8, so on, until you get to your largest size, which for us was 11.5. It looks like. So you put the data in order. And then this is the one where, right, you start crossing off lowest, largest, and keep going until you get to the middle. If we were to do that, you'd find your answer to be 9.5. And then for our mode, right, it's the one that happens the most often. most often there's actually two of them for this, right? We have the number 8 that happens 3 times, and we have the number 10 that happens 3 times. And so our mode is both 8 and 10. 8 and 10. And now looking at this last piece, right, what is our spread, right? We talked about there's 2 ways to do this. One, you can just find the range. So we take 11.5 minus 6, and we get an answer of 5.5. Right, that's one way to describe it. Another way, you could have just said it goes from 6 to 11.5. 6 to 11.5. So right, looking at the data, right, we've done center, spread, and shape. We need an actual figure to do that on, which we'll get to here in a little bit. So first, an example here. It says, what if you want a data entry that you don't have, but you know the average? You know the average. So we got to kind of work backwards here. So it says Mara knew she had an 88 average in her class, in her biology class, but she lost one of her papers. The 3 papers she could find had scores of 98, 84, and 90. What was her missing score? So right, let's think about this. If we're getting an average of 4 tests equals 88, right? That means we added 4 tests together and then divided it by 4. So what I'm going to do is, right, I'm going to add the 4 tests together as 98 plus 84 plus 90, and then plus X, right? We don't know what this missing value was. We don't know what that missing test was. So what we're going to do now, right, to get X by itself, we first have to multiply both sides by 4. Right, once we do that, we now add those numbers together, right? We get 272 plus X equals, and if we take 88 times 4, we get 352. And so our final step would then be to subtract 272, and we get a final answer that she got an 80% on that 4th test. What was her missing score? She got an 80%. So moving forward here, now talking about the actual shape of our data, right? Special shapes to know. These are 3 very common ones that we're going to see, right? This first one, bell-shaped, right? If you can kind of tell here, it kind of looks like a bell, right? We call that bell-shaped. And then we have 2 words here, skewed to the left and skewed to the right. What that means, right, skewed to the left, notice we have a bunch of data here, and then off on the left side, it just keeps going, right? We have small amounts of data. We'll talk about those, right, outliers sometimes. We have data that's pulling it farther out that way, so it's skewed to the left. Now we think the same way here, right, this time, skewed to the right, right, a bunch of data here, and it kind of flattens out, but it keeps going, right? We have a bunch of data that's kind of pulling us off to the right side, so it would be skewed to the right. Skewed to the right. So again, if you need some time here, pause it, but I'm going to get moving forward. So this first example says, what is the shape of this distribution? Right, if we look at this example here, right, if we were to kind of draw on the tops of these here, right, you look at this data and it looks like it's, a lot of the data is right here, but right, it's getting pulled. We have pieces of data out here. It's getting pulled to the left a bit. So we would say that this is skewed to the left. Skewed to the left. So 2 more vocab words, and then we'll get to some more examples here. We'll get to 3 good examples here. So with overall pattern, we have 2 kind of things that might happen, right? Our data is moving along, right? If we notice this green arrow, right, our data is starting to move. It has this pattern to it, right? We might have one of 2 things. First thing is called a deviation, right? Or we call it a deviant, right? You've ever heard the word you deviate from a plan, right? You're changing the plan, it doesn't follow that plan. Notice as we're going along for our overall pattern, this deviant then drops it down. So right, that's a deviation right there. Another one over here is a word we're going to hear a lot in this class. It's called an outlier, right? It's a piece of data, an observation that falls outside of our overall pattern. Best way I think of it is it lies outside of our data. It lies outside of our data. Notice this example. We have all of our data going along, and then we have one piece way out here that's kind of way different than the rest of our data. It lies outside of the rest of our data. So example here, right? We're going to do all three things here. So now with center, right? I'm going to look and go, okay, I can either do mean, median, or mode, right? In this case, I'm just going to do mode for this example. And right, our mode is the one that happens the most. And right, notice that would be this right here. And for this example, our mode would be, we can be a range from 13 to 14. Right, so our center is roughly around 13 to 14. For our spread, right, for our spread here, where we got to think, this is 7, 18's right here. So we'd say our spread is 18 minus 7, which is equal to 11. Or you could have said it goes from 7 to 18. 7 to 18. And now for our last piece, we're at the shape here. Right, we look at the shape. Right, if I were to say anything, I'd say it might be slightly skewed. Right, we can use that terminology. Slightly skewed to the left. Slightly skewed to the left. So right, there's an example there. An example, we're going to go through another one here. So for this one, for center, I'm going to find the median. So what I'm going to do is I'm going to add up all the possible numbers that I have, right? 24 plus 7 plus 19 plus 9 plus 7, 5, 7, 4, 4, 3, 1. So if we take those, add those up real quick, 24 plus 7. We add those all up, we get 90, right? So I'm going to try to find, if we think about middle, right? If there's 90 total numbers, right? The middle would be 45 numbers in. So I'm going to start counting right about 24. Now plus 7, right? We're at 31. Now add 19. Notice in here we are at 50. Right at this point, we're at 50 pieces of data. So that means our median is somewhere in here. So we can say our center would be somewhere around, because this would be 9,000, so it'd be in between 6 to 9,000, right? If you wanted to do 7,500, that would be fine too, right? That would be our median. We look at our spread, right? We start at 0 and we go to about 33,000. And so our spread would be either 33,000 or you could say 0 to 33,000. And then our shape, right? If we look at this one, we have a bunch of data here, and then it kind of gets pulled off to the right side, right? It's getting pulled to the right side, so we'd say it's skewed. Right. Skewed right. Again, if you need to pause it, please do, but I'm going to jump to one more example here. Now for this one, we're going to find, we'll just do median again. We'll do median again. This one's at 14, just so we're aware. So median, right, first I'm going to count how many dots I have. Right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I have 24 dots. So right, starting on either side, I want to count to where's that 12th dot. We're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My 12th dot is right there, which would be at 28. Right, center is 28 miles per gallon. For our spread, right, our lowest was 14, our largest was 33, and so we can write this in two ways. And either way, right, we either get an answer of 19, or you could say it's from 14 to 33. Now, if we look at this one, right, this is an example where it's a little tricky, and right, it's not going to be skewed left or right or bell-shaped. Right, if we look at this one, right, we have some data here, then we have some bumps here, right? And so you have to use describing words as best as you can to describe what does the shape of this look like. All right, an example here, you could say that it is wavy, right? Some people have talked about that it looks like, right, a city landscape, right? You see skyscrapers, you see different buildings up and down moving. So, right, describe it as best as you can with some describing words. So last couple things here is looking at some different data displays, right? So these are just some examples. You're going to see them more often, but we have kind of two types of data that we're going to talk about. Overall pattern only works when you are talking about quantitative data, right? Talking about quantitative data, right? If we look here, our examples are a histogram, a bar graph, a stem and leaf plot, and a dot plot. Right? We've seen some of these already today. You're going to see them more and more this chapter as well. And then overall pattern does not make sense when you're talking about categorical data or qualitative data. Right? That we use pie charts, bar graphs, dot plots. So one example here. Using this pie chart, we're going to read some categorical data and try to answer some questions here. So it says, right, notice one key thing, total people surveyed is 300. It says how many people like pumpkin pie best? Right, if we look at pumpkin pie, it is 30% of the total. Right, if we want to find how many people, we're going to follow this step right here. We're going to take the percent and multiply it by the total amount. Right? What we have to be careful about is we're not going to take 30%, right? We're taking this as a decimal. So right, 30% as a decimal is really 0.30. We multiply that by 300 and we get 90 people. 90 total people. And now this last one here, right, cherry pie, if we look here, cherry pie is 23%, so we're going to do 0.23 times the total. And if we do that, we get 69 people. 69. And so, right, longer lesson here today, but right, talking about all things overall pattern. So that is it for today's lesson on 4.3, talking about overall pattern.